In this lesson, we're going to look at trigonometric identities and the main proofs that you need to know at this level, National 5. Now, before we start, we'll have a wee quick look at this idea of the sine waves and cosine waves and so on, and remind ourselves that the sine waves and cosine waves, they come from triangles moving round a unit circle, or you can be defined in that particular way, with the sine wave being created from the triangles opposite over hypotenuse and so on. So I'm going to look at this triangle in a wee bit slightly different way. So here you've got a triangle, kind of like the unit circle, and you're all sine, tan, cos, but I'm going to concentrate on the all first quadrant, if you like. I'm going to look at a point here, which would be called, we could call that xy, and I'm just using this to prove one of the trig identities. So the coordinate xy would mean that you went x along the way and y up. Okay, so x is the x coordinate and y is the y coordinate. If it was 4, 5, it'd be 4 along and 5 up and so on. The next thing I'm going to do, because sometimes this kind of idea traces a circle round about, I'm going to call this r, kind of define the radius, if you like, of a circle. So you could imagine it like that, a circle being traced all the way around. So that's why we're going to call that r. I've got an angle in there, A. I'll just lock that back in. So I'm now going to look at some definitions I can create from just the x, the y, and the r. So I can look at what is the sine of the angle A in a right angle triangle. Well, sine is opposite over hypotenuse. So I better label this triangle. So that's your opposite side, opposite your angle. This is your hypotenuse, which is opposite the right angle here. And then you've got your adjacent side below that angle. So what does he say? The sine is opposite over hypotenuse. So I can define that with y over r. Okay, that seems okay. And I'm going to also define cos of A. Now, cos of A is adjacent over hypotenuse. In this case, I'm going to use x over r. And finally, to get tan of the angle there, I'm going to use opposite over adjacent, which is y over x. And we can use this principal idea to create the two trig identities that I'm going to look at in this screen and the next screen. Now the first one I'm going to look at is what happens when you divide sine A by cos A, with these definitions here. So if you've got sine A divided by cos A, then sine A is y over r, and you divide that by cos A, which is x over r. Now, division of fractions usually flip the second one over, don't you? And then you multiply. So that's really y over r times r over x. Okay, well you could cancel down the r's at this point, and you get y over x, because you could cancel that down to become 1, cancel that down to become 1. And y over x is the same as tan of A. So that's the first trigonometric identity. To get tan of an angle, you can actually get it by taking the sine of an angle divided by the cos of an angle, of the same angle. Just using some basic definitions there. So let's look at that idea again. Nothing's changed here. I've got the same triangle. I've got the same information here. Sine's opposite over hypotenuse, cos is adjacent over hypotenuse, and tan's opposite over adjacent. And the next proof I'm going to look at is sine squared plus cos squared. What happens when you take sine squared A and add it to cos squared A? Okay, well we know that sine of A is y over r. So we've got y over r squared. And cos of A is x over r, so we've got x over r squared. Okay, so let's square them out. So we've got y squared over r squared, because it's y over r times y over r. And the same over here, we've got x times x over r times r, so that's x squared plus r squared. Now, those fractions have got a common denominator, which is kind of handy, so you can put the top all over r squared. Okay, now here's a wee bit to think about from back to Pythagoras. This is kind of defined from Pythagoras, actually. If you've got x squared plus y squared, then that gives you r squared, just as it would be c squared equals a squared plus b squared. You can define it with these new letters, r squared equals y squared plus x squared, r being the hypotenuse. So that top line is just r squared. Now when you take r squared and divide it by r squared, what do you get? just get 1. So that is your second National 5 trig identity. Sine squared plus cos squared equals 1. And it comes mainly from this idea of Pythagoras here. Okay, now we've got those two identities. You never usually have to prove them. I've not seen that in any exam paper so far. It's quite nice to see where they come from, but I've never seen that you have to explain where they come from. But you certainly have to use them, and sometimes when you use them, rearrangements are handy. And we're also going to talk about this left-hand side and right-hand side. So in each trig identity, the left-hand side is identical to the right-hand side. What do I mean by the left-hand side? I mean the left-hand side of the equals sign and the right-hand side of the equal sign. This is the left-hand side of the equal sign, the tan x, and this is the right-hand side of the equal sign. Okay, so rearrangements are also quite handy, and in the next lesson we'll go into that in more detail. So we've got sine squared plus cos squared equals 1, but this means that cos squared, if you subtract the sine squared to the other side, cos squared is equal to 1 minus sine squared. And also, if you want to get sine squared on its own, you could take away the cos squared from the other side, and you get 1 minus cos squared x. They come in quite handy at this level and at higher. Tan x is equal to sine x over cos x, but sometimes you see this, 1 over tan x. The way I think about that is I kind of think that this is like tan x over 1, and that's been flipped over. So what happens is here is flipped over as well. So 1 over tan is the same as cos over sine. And the last one I'm going to do, if you multiply up by the cos x, you'll get this. Tan x cos x equals sine x. Not so much used, but more this one here. Now, other things that are useful techniques in solving trig identities are multiplying out brackets, factorising, and substitution. But again, we'll look into that in more detail in the next lesson. Right, here's just a category sort to look out for which trig identities are true here and which are rearrangements and which ones are false. So I've got quite a few here to look at, and I'll put them into the correct categories. So sine squared is 1 minus cos squared. Yep, that was true. We looked at that in the last one. Tan is equal to sine over cos. Yep, that's also true. Cos squared plus sine squared equals 1. Yep, that's, I mean, the other one was sine squared plus cos squared equals 1. That seems the same thing. Sine squared x plus 1 equals cos squared x. Nope, that's false. Cos squared minus 1 equals sine squared. No, it was sine squared equals 1 minus cos squared, so that's also false. 1 over tan is equal to cos over sine. Yep, that's true. Tan x is equal to cos over sine. No, it was sine over cos. That's false. Cos squared x is 1 minus sine squared. That's true. Just move that over. Sine squared minus tan squared equals minus cos squared. Nope, that's false. Cos squared x minus sine squared equals 1. No, it was plus, so that's false. And the last one here, sine x is equal to tan x cos x. No, it was multiply up by the cos x. Yep, that's true. So tan x cos x equals sine x. That's true there. So fire that over there. Okay, in the next lesson we'll look at more how to use these and how to solve some trig identities.